सो स्कूल जो एक टॉक अटेंड कर चुका है और एक क्विज अटेंड कर चुका है, आपको, आप वापस से पिकअप पॉइंट पे जाओ। आपको वहां से वॉलेंटियर्स बाकी लैब डेमोन्स्ट्रेशंस के लिए लेके जाएंगे। सो यस, if you have attended one round of talk and quiz, please go to pickup point, find your volunteers, and then you'll go for lab. Surya, can you guide them for the pickup point in the Almond Grove, please? बीच में है तो नहीं आ रहा है, 2-3 मिनट में आता है। We'll wait for 5 or so, because 5 minutes or so, few people are joining. हेलो, सो आई एम सुमन, योर होस्ट। एंड सिंस हमारे पास समय बहुत कम है, तो अब हम अगले टॉक के लिए जाएंगे बाय डॉक्टर कलाइवनन, हु इज गोइंग टू टॉक अबाउट केमिस्ट्री इन बिटवीन द मिरर्स। सो लेट्स वेलकम डॉक्टर कलाइवनन.
Thank you, Suman. Okay. So it's a great privilege for me to stand in front of you people. I thank the organizing committee for giving me the opportunity to speak in front of the vibrant minds of future India. So I'm really feel great to be here. So the next 20 to 20 minutes, what we are talking about, I'll talk about is like something about the fundamentals of molecules and materials. Okay. So how many of you study chemistry as a subject? Wow. Okay. Then we can discuss something better. So the title of my talk is chemistry in between the mirrors. Okay, before going into such a very novel research topic, we should know something about the basics of chemistry, what we are really talking about. So we all know what is chemistry. Chemistry is about studying molecules or materials and what is a composition, what is a structure, and what is a property, which includes physical, chemical, and biological properties also. Okay, so how many letters are there in English? 26. How many words you can make with it? Sorry? Numerous. Okay. So you think about chemistry, which has nearly 118 elements. Okay. Only these are the elements which is available in the universe. Only by using these 118 elements, everything is made in the universe. Okay. So the elements are given in the periodic table that we all know. So what is periodic table? Okay, so now the periodic table gives you a glimpse of how the atoms can be arranged based on their number of electrons and protons and nucleus available in the system. So we all know atoms are made up of electrons, protons, neutrons. Okay, depending on how many of the numbers present in the atoms are different in their behavior. Okay, for example, if we just take hydrogen. Okay, hydrogen is the smallest element in the periodic table, right, which has only one electron. So one electron, one proton, and one neutron. Okay, similarly, if you think about oxygen has 8 electrons, 8 neutrons, and 8 protons. Okay, so the only difference between them is the number of electrons and protons. So we all know that the nucleus is made up of protons and neutrons. The electrons are around roaming around the nucleus. So this is the structure of an atom. Okay, but are we seeing the atoms? So what most of the systems or what are materials what we are using are made up of molecules. What is the difference between molecules and atoms? So the atoms are coming close to collide to form molecules. Okay, so now the atoms are coming close and they collide with each other, they react to form molecules. If you take this hydrogen and hydrogen and oxygen molecules, when they collide, they form the water molecules. Okay, so what is the difference between water molecule and hydrogen and oxygen atoms? So we should know what is the difference between them, right? If you think about the electrons, so only one electron is roaming around the hydrogen atom. Here you had 8 electrons, but in the molecule, they are sharing 1 electron between each. Okay, now if you take hydrogen and oxygen molecule, you can see the yellow electron is coming from the oxygen, the blue one is coming from your hydrogen. Once you form this particular molecule, this hydrogen electron is shared between hydrogen and oxygen. Similarly, one of the electron from oxygen is shared with hydrogen and oxygen. Okay, so this sharing, the sharing of electron between the two atoms, forms something called chemical bond. Okay, that is the very fundamental of any molecule. Okay, if we can make a chemical bond, it means you are making a molecule. Okay, how do you make the bond? How do you break a bond? It's all about chemistry. Okay, how easily you can make or how hard it is, so you can tune the chemical behavior of the materials. Okay, but don't know, you know what is about this water molecule? It is not only water, right? Everything around us is made up of atoms, starting from the smallest molecule, hydrogen molecule, to the largest of your proteins and like DNAs, all are made up of atoms, of different atoms. Okay, if you, for example, if you take, you know about carbon dioxide? Recently, we are hearing in all the newses everywhere carbon dioxide. So what is the importance of carbon dioxide recently? You know what is, yeah, please. Why? So, okay, good. So greenhouse gas. Why you should know about greenhouse gas? What is the importance of that? Yes. Okay, it's called global warming, right? The global warming is the main, the big trouble in front of us for the future generation, the global warming. What it is doing? It is warming the earth. Okay. It has the structure of only, it has carbon and oxygen molecule. Okay. Why? How it is forming the global warming? Why it is responsible for it? All these things, it involves lots of spectroscopy. So, but we are not dealing that now. But these are the only elements which are present in the carbon dioxide. Similarly, you know what is glucose, right? What we are eating every day, rice is made up of sugars. So this is the structure for your sugar, the glucose. Or every time when you are taking paracetamol, when you have headache or any pain, you have fever, you take the paracetamol, it has this particular structure. So like that, if you think about heme, which is transporting your oxygen molecule in your blood, is made up of these particular structures. So the leaves are using these particular structures to trap the sunlight or to do the photosynthetic things. So all these things are about chemical structures. But are we really seeing them in your life? If you think about water, are you seeing this hydrogen and oxygen in your glass or bottle? Why we don't see? Yes. So they are very small in size. Okay. So if you think about the size of a water molecule, it's like the diameter of the molecule itself is only 0.3 nanometer. You know what is the diameter of your small thin hair? The single hair, what you have? You know what is the diameter of it? It's in microns. Okay. So now if you think about this structure, this diameter is already 10 to the power 4 times smaller than the hair. So it is very difficult to see them. Even with the microscope, you cannot see it. Okay. These are so small. But in reality, this is what water for us. Are you seeing anything if you're in your home? Are you asking your mother, can I get a glass of H2O? No. Why? We don't use that words. If there are chemical terminology, we don't ask them like, can I have a glass of H2O? You always ask for water. Okay. Similarly, the table salt, what you are using in your all over food, which enhance the taste, it is made up of sodium chloride, which has sodium and chlorine atoms. Okay. How do you see them? It's like liquid or solid? It is solid. It's like kind of crystalline material, right? But if you think about rice, which is made up of carbohydrate, what is the structure of it? What is the morphology? It has solid, some kind of brittle, it's not crystal, but it has different structures. So how you can have different morphology and different structures for a material? What dictates it? How you can see water as a liquid and sodium chloride as a crystal and rice as your other flakes. So if we think why it is forming like that, we should know more about how the molecules are formed. Okay, what is the composition of it? So now if you take about hydrogen and oxygen, they form water. Now, if you zoom in water, this is what we expect. Okay, all the water molecules are moving around in the water molecule. Okay, there is nothing other than water. So if you see this one, we know already 18 gram of water contains Avogadro number of molecules. What is the Avogadro number? Yeah, 6.023 in 10 power 23 molecules are present in 18 gram of water. So if you do 10 to the power 23 division, you will see a molecule. Okay. So now this is about water molecule. Then if you think about the properties. So if I think about water, so how it is it colored? No, it's a colorless liquid. Does it have any taste? If you don't add any minerals, there is no taste for it, and it's kind of, there is no smell. And you will see in chemistry, you will study something, it's a polar solvent. Okay, do you know anything about polarity? Yeah, what is it? Yes. Okay. So now what temperature it boils? 100 degree it boils, at 0 degree it freezes, it has a pH of 7, it has a certain density. But who determines all these things? What is the parameter which dictates all these properties? Which has only oxygen and hydrogen atoms. There is nothing more than that. Okay. If you want to understand why this water has this kind of properties, we have to little more go close into the molecular structures. Okay. So if we take water molecule, now again I am taking the water structure. It is made up of oxygen and hydrogen. Okay, already I told you they are sharing an electron to form the chemical bond. Okay, so but when they are sharing, what do you mean by sharing? Mutual. Okay, I am giving an electron to you, you are giving an electron to me. But is it that natural? When you see two kids, how they play, when they are sharing the toys, do you see they are share equally? Who is getting the better one? One who has the more power, or one is who can fight for it. Okay, like that, atoms also has the behavior. Okay, so atoms has something called electronegativity. What is the meaning of electronegativity? It is a power of pulling the electron towards it. Okay, who has the more power to pull the electron towards it, it gets the more electron. Okay, so if I consider, if I take this particular systems, oxygen has electronegativity of 3.5. You think about it's a general grade, you can take like no need of a unit and all. So it's a 3.5 and compared to hydrogen it is 2.1. So from here what you can see, oxygen is pulling the electron towards it. Okay, now it's no longer mutual sharing. Oxygen is kind of showing power. So because of that one, you will see something like there is a flow of electron in the molecule. Okay, now the oxygen is pulling the electron towards it. It generates something called asymmetric cloud, electronic cloud distribution around the molecule. Okay, now oxygen has more of negative charge, hydrogen has more of positive charge. Okay, so now you see that the red color always in chemistry, when you go to see anything, the red pronounce that more negative and blue pronounce more positive. Okay, so now you have positive and negative charge generated in the molecule. This particular thing gives us something called dipole moment. What is dipole moment you are studying in science? You might have studied in your physics, if not in chemistry. What is dipole moment you are not studying? So the how much charges are separated for a distance. If you can separate the charges, you generate a dipole moment. If the charges are not generated, there is no dipole moment. They are non-polar. Okay. So if you think about this particular system, now you generate a dipole moment in the structure. You have a positive and negative charge generated. So this has a permanent dipole moment. Okay, which makes a molecule polar. If it is not, if doesn't have a dipole moment, then it is non-polar. Okay, for example, if we just take an example, if you think about hydrogen and oxygen, okay, hydrogen molecule is made up of two hydrogen atoms. Okay, oxygen is made up of two oxygen atoms. Do you expect them to be polar? No. Why? Exactly. So the electronegativity is going to be same. So now they cannot pull the electron towards any of that. So it is going to be symmetric. Okay. So now the dipole moment for this particular molecule is going to be zero. Due to the zero dipole moment, you call them as non-polar molecules. Okay. Any molecule, it is not only for water or hydrogen or oxygen. Any molecule, if it is symmetric in structure, okay, having all the elements same, it is going to be non-polar. If we have any structure which is asymmetric or which has kind of different elements present in that one, you will generate the molecule which are polar in nature. Okay, this is the main difference between polar and non-polar depending on the composition of the molecule. Okay, so now this particular dipole moment dictates how this molecule should interact with the other molecule. Okay, now you already know the molecule has a positive charge and negative charge. Now positive will attract negative, correct, right? That is what our laws of chemistry or law of science. Whenever you have positive charge, it will attract the negative charge. So we know the protons are positive charge. Now from here you will have oxygen as negative charge. Now the positive charge of water will attract the negative charge of your other water molecule. So now this is what your structure of your water molecule. Okay, when you think about one water molecule, this is what the structure. But when you go to the condensing waters, like kind of when you think about liquid water, which has more number of molecules, they will have this kind of interactions. Okay, now you have two different kind of interaction. One is like covalent bond. What is covalent bond? Which was formed by sharing the electrons. Okay, which is there in even your single molecule. But non-covalent bond, which is happening between the two molecules, which are not by sharing the electrons. Okay, which are because of these interactions. These are all electrostatic interaction between the molecules. So these are the two kind of bonds which are there in water molecule, which dictates all its properties. Okay, how you can see how it is manifested, I'll just show you now. So now if you think about water molecule, which is again made up of H2 and O, you see ice, water and steams all are made up of water, right? Is there any difference between the composition in your ice and tap water or the steaming water? There is no difference. All are made up of H2O. Okay. But what is the difference? What makes them to be one to be solid, very static solid? One it is flowing liquid, other one is kind of steaming out. Is there any difference? So how you can differentiate them at their fundamental? So if you think about that, you can transform one to other by changing the temperature. Okay, but if at 0 degree it is ice, you just warm it, it become liquid, and again you warm it, it is going to boil it. If you see the microstructures, if you zoom in, you are going to see the very few molecules in the structure. It is going to be like this. Okay, so now you see here in the solid form, your covalent bond and your weak interactions, the hydrogen bond, non-covalent bond, are very static. They are very much frozen. Okay, so now they are very stable. So because of this stable structure, now the water molecules are not moving around. It is kind of frozen. So when it is frozen, you cannot move around. It's kind of like all energy is lost. When energy is lost, it's going to be like very stable form. It is kind of solid form. Then, you know, all the time ice floats on water. Why? How the density is lesser? Yeah. So now if you see this structure, now between these water molecules, there is a space. So vacant space generated between the structures. So it is built, it is what? It will have, if you have air molecules, air will be trapped inside. Okay. So because of that one, it will have less density when compared to liquid water. So but if you heat it, some portion of the hydrogen bonds or non-covalent bonds will be broken. Okay. Once some of the broken, then you don't have the kind of frozen state. Now the freestanding. So this particular water molecule, it is not connected to other side. So what it can do? It can rotate. It can do all the tumbling motions. So when it can do the motions, it can be free flowing. Okay. So now you get the free flowing water molecule. But if you go to the other structures, steam, now you completely break all the non-covalent interactions. Now it is kind of like again all the water molecules are free. So now they can do wherever they want. Go. So in that structure, you will see all the water molecules are monomeric in nature. You don't see them again. Do you see the steam? Do you see the steam? You feel it, but you don't see it because again the water molecules are so tiny in nature, so you don't see them. So this is the main difference between your ice, water, and your steam. But in all these structures, if you see, there is something, the covalent bonds are intact. Do you see covalent bonds are breaking? No. From solid ice to the steam water, it is going to be H2O. Only the weak interactions are broken. So what is the meaning of it? So if it is having a better weak interactions, non-covalent interactions, it can be in different states for a long time. If you further ways, we can say like these electrostatic interactions between the two molecules. You already know the van der Waals interaction, right? This word you might have heard. Van der Waals radii you might have heard in your thermodynamics. Yeah. So that can be manifested to van der Waals interaction. So the van der Waals radii tells you how close they can go. The interaction will be at that particular van der Waals radii. Okay. So now if you have stronger the non-covalent interactions, when your non-covalent interactions are so strong, this will have higher boiling point, higher freezing point. But if you are like kind of when they are weak, you will see their boiling points are lower. Okay. So now this is what it is. Now you have the, already know the DNA, right? We all study the DNA. DNA is stable only because of hydrogen bonding between the base pairs. You know what are the base pairs available in the DNA you are studying? What is it? Adenine, guanine, cytosine, thymine. Okay, in that two are like hydrogen bond donors, two are hydrogen bond acceptors. Okay, by seeing the structures, you will see there is hydrogen bonding between them. Only because of those hydrogen bonding, it is stable. Okay, even when during the discovery of the structure, Watson and Crick developed that one. Till understanding the hydrogen bonding, it was not known what is the structure. Only the hydrogen bonding made them to identify the structure. So, okay. So now if you think about this particular structure, now we will go into like what happens between the molecules. Now if we take this particular molecule, water molecule, now as I told you, the distance between the two atoms, hydrogen and oxygen is nearly 0.1 nanometer. Okay. but between the two molecules, it is 0.2 nanometer. So what is the meaning of it? When I have one molecule, which is water, which has these two atoms are at the distance of 0.1. Now this distance between the two atoms at two different molecules, it is 0.2. So there is a more space between the two molecules. Okay. So in other words, we can just see in this way. So I have a water molecule. I have other water molecule which is having the electron density. Now there is some space between them, excess space. Okay. What is there in that space? Sorry? Hydrogen bonding is there is no bond. There is nothing like a stick or something between the atoms. So there is some only interaction. But this distance between the two atoms bit longer than the distance between the two atoms in the molecule. What do you expect? What do you expect there to be? Space. What is that space? Okay. So now to understand that what is that space, we will do a thought experiment. Okay. So now this is what we have to understand. So now if you think about sound wave, okay, I am speaking from here, you are hearing it, how it is propagating to you? Particles. So what we have in between us? What is there? Air. Okay. So now we have air in between the source and detector, not vibrating, and you're hearing the sound. If you think I put a vacuum box, what is a vacuum box? What is vacuum? Nothing. Okay. So now I removed all the air molecules between my source and your detector. So now do you think you can hear the sound? No, you cannot hear the sound because sound wave cannot propagate through the vacuum. But if you think about light, okay, light also same thing. I can do this. I can just switch on the laser. It is coming to that. You are seeing that also. Again here, if I put a vacuum box, what do you expect? It travels. So the light can travel through vacuum. But vacuum is what? Vacuum. What is there in vacuum? Nothing. But how nothing is transporting the light? Yes, energy. But how it is propagating? Waves. So in the vacuum, there should be something to propagate the light waves. Correct, right? So what is light? Waves, electromagnetic radiation. So what is electromagnetic radiation? It has electric field and magnetic field. Okay, whenever you are thinking about a light, it has both electric field and magnetic field. So those light waves, when they are hitting the vacuum box, still it is propagating through. Unlike sound wave, it is propagating in the vacuum. So in the vacuum, there should be something which can propagate the light wave. Okay, you bear with me. There is something called vacuum fluctuations. Okay, this word or buzzword you will hear when you are coming to that higher studies in physics, or it's going to be more and more pronounced in the future time. You will hear about it, vacuum fluctuations. So those vacuum fluctuations are again electromagnetic fluctuations. Okay, you cannot avoid it. It is there everywhere. So if you think about the universe, you think about any space in the open space, you don't see them, but it is filled with fluctuations. Okay, that's the reason you cannot attain the, thermodynamics, third law of thermodynamics. What is it? You cannot reach the 0 Kelvin. Correct, right? You cannot reach the 0 Kelvin because there is always a bath fluctuations. So there is a bath of fluctuations. Those fluctuations are none other than the vacuum fluctuations. Okay, these vacuum fluctuations are inevitable. You cannot avoid it, even if you go to vacuum. So what is the meaning of vacuum? So now I take a box. You here, if I take an imaginary box, I have air molecules. I suck out all the air in outside. So I have vacuum. Even there are some fluctuations available. Okay, those fluctuations are vacuum fluctuations or quantum fluctuations. These quantum fluctuations are responsible for your something called virtual photons. You will hear in your in the evening talk or in the future physics. So those are called virtual photons. They are, even if you know about the Feynman, who is a well-known physicist. So he was the one who really coined the terms of virtual photons. Though virtual photons are there around the molecule, so they are interacting with the molecule all the time. Okay. So now each propagates the communication between the molecules and it governs all intermolecular interactions. Can we tune them? Is it so? Now, as I told, if between the two water molecules, these fluctuations are there. Okay. Can we tune them? Is it possible to tune? If we can tune that, by tuning that one, can we have a different environment for the molecule? If we can bring a different environment for the molecule, can we tune the properties? That is what exactly what I am saying about chemistry in between the mirrors. Okay, if you go to the mirror, what you can see in the open space, you are going to see all the fluctuations. But when you put, so in the fluctuations, we'll have all the energy possible. Okay, what is the fluctuations? Whenever you think about radiation, it has its own frequency, it has wavelength. So those frequencies, depending on the frequency, what you will have energy. That is given by E is equal to h nu. Correct, right? So if the nu, if I can tune it, I can change the energy. Okay, if I go to the mirror, so what mirror will do? Mirror is going to reflect the light. Correct, right? What mirror will do? If you are sending a light to a mirror, mirror will reflect back. Okay, if I give two mirrors parallel to each other, what it will do? It is going to form a standing wave. It is going to reflect back and forth. This whatever mirror it is reflecting, the other mirror will reflect. So they will have a standing wave generated. What is a standing wave? They will only few frequencies can survive inside, which satisfies the boundary condition. What is the boundary condition? When the light is reflecting, there should be something like a phase. Okay, now if you think about this particular structures, you see it is off lambda. You know about lambda, right? Wavelength. Yeah. So this is off lambda, 1 lambda, 3 by 2 lambda, 2 lambda, 5 by 2 lambda. Only those particular frequencies will survive inside. All other frequencies will be destroyed. Okay, because of the reflection. So now I have something called the modes. The energy inside the cavity is going to be only this one. Instead of having all the energies, I have only certain frequencies. So due to that one, I can tune the energy inside the molecule. Okay, by tuning the energy, you can do a lot more inside the chemistry. So I'll just skip these things. I'll just take you to one small thing. Okay, so now you have to tune the energy. To what frequency we have to tune it? If you think about water molecule, how it can store energy, whether it can rotate, it can vibrate, or it can be electronic excited. So you know what is the rotation? You all use microwave oven. So you know how it is working? Microwave oven. Okay, so now if you think about the distance in your microwave oven, there is a box. Okay, there are two mirrors kept at the exits. Okay, so now the length between the two mirrors are matched in such a way they will match with your rotation. Okay, the rotational energy is matching with the mirror between the thing, and the frequency of the mirror is tuned for the rotational energy. So whenever you switch on your microwave oven, the energy which is generated will be used for this particular process. Okay, when it is completely rotating very fast, it will get heated, it will get warmed up. So this is what the microwave is doing, but you can tune the cavity, you can tune the mirrors to this particular energies or this energies or here, anywhere you can, by changing the distance between the two mirrors, you can tune your frequency. So by doing so, you will generate something called, it's a very small clip you can see. Three minutes. Okay. It is called the web because it traps electrons in its plane. So now a molecule is kept between the two mirrors. Okay, the molecule, don't worry about exciton and all, just see what is happening. So that is the energy which is inside the cavity, inside the mirrors. Okay. Now electron is rotating around the nucleus, it has certain frequency. Eventually, the exciton combines when the electron falls back into the hole. The energy is released as a light wave with the same frequency as the one which originally created the exciton. The quantum well is then placed in the plane that intersects the peak of the light wave. So, when the microresonator is calibrated so the resonant light wave and the exciton have the same energy, a single exciton can be converted into a light wave, which then converts into an exciton, and so on. The resonant optical cavity can trap the light wave emitted by the exciton so that it returns and creates another exciton, which also decays. A repeating cycle between the light wave and exciton is made possible. Since the exciton and light are constantly interchanging, they behave overall for a new couple called the polariton, which has some of the properties of each. Okay, so now when you have the molecule inside the cavity, inside the mirrors, they will exchange energy. At some point, you will see material is not material, it has some part of light character. So once you have that particular thing, you can see varieties of chemistry can be changed, variety of science can be studied. So this field of science is called polaritonic chemistry. Okay, this field is in the nascent phase. So any of you can come up and do your contribution to the field. Okay, I hope to see you somewhere in this field, so you can do something to the chemistry. Okay, with this, I would like to thank the committee and your kind attention. So I'm happy to answer any of the questions if you have.
Okay. Thank you, Kalaivanan, for a wonderful talk. We can have two questions. So you can raise hands. If you have question, then you can proceed with the question. Okay, so yes, please.
Thank you. You mentioned there is some residual fluctuations in vacuum. Is it because we cannot create perfect vacuum, or even in perfect vacuum theoretically?
Like gravitational force. Vacuum fluctuation is one of the force which is available in the universe. You cannot avoid it. Even if you go to perfect vacuum. You will hear about those things. It's not exactly we can use it because they are the virtual photons lifetime is so small, so we cannot trap that even. So only thing is you can feel it or you can use it for some other thing. You cannot use them exactly.
You said that quantum fluctuations are EM fluctuations, but what causes them? If you have an isolated system, would this still happen?
So if you think about universe, the universe is filled with even if you think about sun. Okay, so do you think sun is sending only light or it has any electromagnetic radiation? So that itself is source of your ions. So whenever you have electric charge, the electric charge will have infinitive electromagnetic fluctuations. Correct, right? When you have any charge, when the charge is moving, we all know that the sun is moving, all the objects are moving, all are charged by species. So when they are moving, they generate this. They can go for longer distance. They are the very fundamental source for all your fluctuations. Yeah.
Okay, so we will not take any questions further because we are really short of time. तो कई लोगों ने बाद में ज्वाइन किया है टॉक के बीच में. सो बट डोंट वरी, आपके लिए आधे घंटे बाद एक और टॉक है. सो उसके पहले आपके लिए क्विज है. तो इसके पहले कितने लोग क्विज में थे? या आई सी फ्यू फेसेस एंड आई रिमेंबर देम. ओके, सो क्विज के रूल्स हम यहाँ डिस्प्ले करते हैं. वी आर अ टीम ऑफ 4. विल कंडक्ट द क्विज.
Yes. Function plus function.
जूम को पहले बंद कर दीजिए. नहीं, जूम को बंद कर दीजिए. नहीं. कहाँ था वो वाला फंक्शन प्लस क्या था?